Hi, everyone. Just wanted to take a moment to talk a little bit about using angles and proofs and making sure that we're all comfortable with the angle addition postulate and using it for solving angles and then solving different proofs. So, one of the big things of the angle addition postulate is basically if we know the measure of a bigger angle, we can add together the smaller parts to equal the total angle, right? So we know that angle UVW, that's a straight angle, so it's 180 degrees. And we know that it's made up of UVX or eight, it's made up of 8, 7, 6, and 5, right? So all of those added together must equal 180 degrees by the angle addition postulate. So to solve something like this and to figure out what x is and then subsequently what all the individual angle measures are, all we're going to need to do is just add them all together and set them equal to 180 because we know the big overarching angle. So we have 5x plus 4x plus 6 plus 10x plus 12x minus 12 is equal to 180, right? And that's just coming from the fact that we have 5, 6, 7, and 8, and we know what all of their measures are because that information is given to us. So if we combine everything, we have 5x plus 4x is 9x, 19x plus 12 is going to be 31x. We have 31x, and then we have a 6 and then minus 12, so minus 6 is equal to 180, right? So 31x is equal to 186. So we know that x then, if we divide both sides by 31, that should just be equal to 6. So x would be equal to 6. So to figure out the individual angle measures, we could just plug it in. So the measure of angle 5 is equal to 5x, so 5 times 6, which is 30. The measure of angle 6 is equal to 4 times 6, which is 24, plus 6, which is also 30. Measure of angle 7 is going to be 10 times 6, which is 60, And then the measure of angle 8, again, we can plug it in. 12 times 6, 72, minus 12 is 60, right? And there you have it. So that's what each of the angles measure. And then once you had found just these three, you could have just figured out what was left, and that would have been 8. All right. So let's move on to kind of sorting ourselves over towards proofs. Determine whether the following statements are sometimes, always, or never true. So two angles that are supplementary or complementary. Well, remember, supplementary means that they add up to 180, and complementary means they add up to 90. So if we have two angles that are supplementary, but they can't also be complementary because then they would be adding up to both 90 and to 180. So this is going to be never. All right, complementary angles are congruent. So again, complementary angles just means that we have two angles that are adding up to 90 degrees. So it is possible that they could be congruent. It is not necessarily true, right? So, if I had 47 and 43, those would be complementary, but they wouldn't be congruent. But if I had 45 and 45, that would work. So they could sometimes work. All right. So now what we're going to do is we're going to move into the actual proofs. And hopefully at this point, you'll be kind of used to some of the structure and you'll kind of anticipate some of the things that we'll get to do. The big thing with this one is really utilizing the angle addition postulate appropriately. So we're given the information that the measure of angle 1 is equal to the measure of angle 3. All right, so we know that 1 and 3 are congruent. I'm sorry, whether the measures are equal. We could then follow up and say that they are congruent using the definition of congruence, but it just tells us that the angles are equal, their measures. All right, so our goal then is to prove that the measure of angle EBA and DBC are actually congruent. All right. So what do we have? We have that the measure of angle 1 is equal to the measure of angle 3. That's given to us. We also have the information from what somebody else would have started filling this in with, saying the measure of angle EBA is equal to the measure of angle 3 plus the measure of angle 2 by the angle addition postulate. So we know ultimately at the end we're going to need the measure of angle BC. So let's see if we can do anything with that. Well, we did this, right? EBA, and we said 2 and 3. So we can use DBC and say 1 and 2, right? So the measure of angle DBC equals the measure of angle 1 plus the measure of angle 2, all right? And again, that's just going to be the angle addition postulate. And that's going to be a really helpful postulate for us as we're going along with our proofs. All right, so at this point, there's actually a couple steps you could take. And what we can do is we know that 1 and 3 are equal to each other, right? So I can just substitute this 1 here for the 3. So I'm going to do that. The measure of angle DBC is equal to the measure of angle 3 plus the measure of angle 2 by substitution. Okay? Substitution. I always spell that wrong. Substitution. And then finally, we know that both of these are equal to the same thing, right? So they're both equal to the measure of angle 3 plus the measure of angle 2. So then, by substitution, once again, I can say that the measure of angle EBA is equal to the measure of angle DBC. And again, we're just using substitution. All right, so now we're done. Use the little square, the QED, whatever you prefer. All right, so let's move on. Let's look at another one. All right. So, oh, that moved. Sorry. Let's move that up a little so I can move that up and have a little bit more room for that one. All right, so let's fill in the blanks here. Segment BD is bisecting angle ABC. So we know that ABC is bisected. All right, and then 1 and 3 are complementary, and then angles 2 and angle 4 are complementary. So let's look at what we have here. Obviously, the first thing that we're given, that's obviously going to just be a given, right? The first step is always going to be a given. Now, you could have, if you really wanted to, put all of these in one step, but you don't need to, all right? So you could have, but you did not need to put all the givens in one step. So we have 3 pieces of information that are given, 1, 2, 3. So obviously this blank here is going to be the angle 1 and angle 3 are complementary. I'm just going to write com. All right. So why are we able to say that 3 and 4, angles 3 and angle 3 and 4 are congruent? Well, what do we know about bisecting? Bisecting just cuts an angle in half. So that means if they're cutting in half, they're congruent, right? So that's going to end up being the definition of bisect. And then why is 1 and 2 congruent? So we have that 1 and 3 are congruent. We have that 2 and 4 are congruent. What do we know about 3 and 4? Well, they're congruent. So what could we have said? We could have, essentially what we can do is we can substitute that to be 4, right? And then we have 1 and 4 are congruent, are complementary, and then 2 and 4 are complementary. And when angles that are complementary to the same angle, then they are congruent. So angles complementary to the same angle are congruent. All right, and now we're done with that one. So again, just remember bisect cuts it into 2 equal parts. So when it cuts into 2 equal parts, they are complementary. I'm sorry, they are congruent, not complementary. All right, last thing. Let's do one from scratch. So we are given if angle 4 and angle 5 are complementary to angle 6, then angle 4 is congruent to angle 5. Now this is actually how to prove the congruent complements theorem, which was saying if complementary angles are congruent to the same are if two angles are complementary to the same angle, then they're congruent. So we're actually just going to go through and prove this. So we're not going to be able to use this theorem to prove the actual theorem itself, right? So let's see, what information are we provided with? So let's start off, obviously, with our given, our statements, and our reasons. Statement and reason. So 1, obviously, we're given that 4, angle 5, they are complementary to angle 6. That is a piece of information that we are given. So we're going to start there. All right, so we're given. 2, well, we're given that they're complementary. So ultimately, what does that mean? Well, let's just use the definition of that. The measure of angle 4 plus the measure of angle 6 is equal to 90. And then it also means that the measure of angle 5 plus the measure of angle 6 is equal to 90. Okay? So the reason behind that is that's just what it means to be complementary, right? That's our definition of complementary. Oops, that's a 3, not an 8. There we go. All right, so now we have two things equal to 90, so we can set them equal to each other. The measure of angle 4 plus the measure of angle 6 is equal to the measure of angle 5 plus the measure of angle 6. Right, and then we'll just use substitution. So 4. Now, what can we use? Well, we can use the subtraction property of equality. And from the subtraction property of equality, we can ultimately get that the measure of angle 4 is equal to the measure of angle 5. Now, if you wanted to, you could show both sides and say subtract 6, subtract the measure of angle 6 from both sides, and then write another step where you use substitution as your reason. But I'm just going to write this and say the reason behind that is just subtraction. That's perfectly fine. Okay, subtraction, and then 5. Last step, we have 4 is congruent to angle 5. And this is going to be a very common ending step. It is just that this is the definition of congruent. Technically, it's the definition of congruent angles in particular, but overall, we know it's just the definition of congruence in this particular case in relation to angles. So let me know if you have any questions, and best of luck. Have a good day.